Hi, hello everyone. So this is Ravinder. Now in this video, I am going to explain how to build a machine learning model. That means what are the different steps over there to build a model. Now in this video, I am considering some example. So based on that example, then I'll explain how to build a machine learning model with the different steps. Okay, now let us assume that we are given a marketing budget. So in order to sell a product, so we have to marketing it. So how much amount we are spending to sell the product. So here this line indicates how much amount we are spending on marketing, right? Now while spending, how many subscribers we are gaining, right? So this line indicates the budget, and this many how many subscribers we are gaining for last 8 months. So based on this data, I'm going to explain about how to build a model. So as you can see, there is a trend or relationship between the amount spent and new subscribers gained. Yes, in the previous this one. So we had once you observe this trend between this marketing budget and the subscribers gaining, for each and every month. So January, February, March, April, May, like that. Once you observe it, we can conclude that entire table in mathematical way. Means what? Subscribers gained is equal to 2 times of amount spent plus 40. So that is trend is there in that table data, right? Before building the model, we have to discuss about these many features. Okay, right. So we require a feature. The feature means what? Inputs. We require some input. We have to gather input from various sources. Depends on a project. Depends on model. We are going to develop, build. You may build a supervised learning model. You may build a unsupervised learning model. You are building by using reinforcing learning model. So based on that model, we have to gather the data from different sources. That is what feature. Now coming to the labels. The label is what the label represents output of our model. For example here, a pair of inputs and outputs used during the training process. In this case, the pair of values, market underscore budget, that represent how much amount we spent in so and so month and how many subscribers we gained in second column. And coming to the model. So that machine learning model is a mathematical representation of a real world process. In machine learning model, it is an artifact or entity which is created by using a class of algorithm and training it with the features and labels. Means the machine learning model is an artifact or entity which works on inputs and it predicts some output. The goal of this model is to find out what relationship between independent variable and dependent variable. Yes, the machine learning model, the main aim of the machine learning model is to build a relationship between independent variable and dependent variable. Let's say you want to build an application. Just I'm giving you an application of machine learning. Once you want to build an application that can recognize users' emotions based on the facial experience, is that we have to build an application that has to identify person's emotion based on their facial experience. So that is what one model. So in order to find out the facial emotions based on the face experience, we have to train the model. We have to build the model. So we have to build the model by giving the different images of faces. We have to give different images of different faces with tagged with certain emotion. That means one image with a different types of emotion and different image with different types of emotions. Once you train it and build the model, that application will simply definitely identify the concerned image facial emotion. Now we have to gather the database, the sources, input, we have to gather it. Then we have to build the model, train the model. Then we have to select a learning algorithm based on types of learning algorithm. For example, if you are developing by using supervised learning algorithm, we have to select a naive-based learning algorithm. Or else we are using, unsupervised learning algorithm, right? Or you can use reinforcement learning algorithm, right? Now we have to choose first of all learning algorithm. Then we have to build it. We have to build the model. So that is what we discussed about, one application of machine learning. Now these are some steps to build a machine learning algorithm, right? Now first one is data preparation, feature gathering, and data modeling, and performance measure and performance improvement. All these steps we can discuss one by one. Yeah. So collecting data and choose learning algorithm. After choosing learning algorithm, then we have to train the model and build it, right? So this is what data, right? This one is what data. We have to gather the data from different sources based on the particular project, based on particular learning algorithm, based on type of machine learning algorithm you are using. Then choose the learning algorithm and train the model and build it, right? How we can perform all these processes, we'll discuss one by one. It requires features and labels already we discussed, right? Yeah. The first step, we have to create a notebook, right? So we can use different notebooks are there in the model, in the market. We can use Anaconda, Jupyter, or Colab, right? Yeah. After creating a notebook, then we have to import dependencies, libraries based on your project. Whatever project you are going to develop, based on that you have to import some dependencies or libraries. For example, you are developing a model. If you want to use TensorFlow, then we have to import TensorFlow, NumPy, Pandas, etc. So this is the second step to import dependencies and libraries we are going to implement it. For example, NumPy, Matplotlib library, TensorFlow, and Pandas, etc. So by using that import command, we can import all these libraries, right? Once you import all this library, then we have to import set of data points. That is very important, the crucial step in modeling machine learning, right? So we can give data directly in the form of arrays. That array may be one-dimensional, two-dimensional, one-dimensional. We can create arrays by using TensorFlow. In TensorFlow, we can create arrays by using tensors. The tensor may be the one-dimensional, two-dimensional, one-dimensional. Or else we can download by using load method. We can download it. That is the step 3. So in step 3, we can generate or import set of data points. Alright. Now, according to the present example, we are using budget spent and number of subscribers gained. Now here I am using this one. Just I'm using one array, right? 60 in the month of January, I spent $60,000. In the month of February, I spent $80,000. In the month of March, I spent $100, 30, 50, 20, and like that. So this is what one array which is belongs to what budget we spent, right? And how many subscribers we gained? Yeah, this one. Sub underscore gained. So like we can collect data points or else we can load it. After this step, then we have to separate out the data, the whatever data we gathered, we have to separate out. How we can separate? Now, what is the meaning of separating the data? That means, before building, if you want to build a model, we have to train it and we have to test it, right? So to train the model, we require testing, the training data, and if you want to test the model, we require test data. That means the total data is divided into two parts: training data and testing data. Yes, testing data as well as training data. Right. So the training data is to train the model, and testing data we have to kept aside. After building the model, we have to apply on the model and test the model in order to get the accuracy value. Now, how we can split the data into two categories and mentioned in Python. So in Python, by using train underscore test underscore split method, we can split the data into two categories. Now, as per the current example, I took here, the marketing underscore budget and subscribers gained. These two data, these two arrays we gathered. Now, these two data points divide into four categories. That means here, training data, testing data, these are two inputs, and Y-train and Y-test. So Y-train means what? The actual output, and Y-test means what? The predicted output. So this is what Y, this is what YP. YP means what? Predicted output. So this is, expected output. Y means what? Y means what? Expected output. Expected output. And YP means what? Predicted output. Now these two are what? Inputs. Inputs at training, input at after building the model. Clear? Yes. Now coming to the step 5. Now we have to create a model. So in previous 4 steps, just we created a notebook and we downloaded all the dependencies, libraries like TensorFlow, NumPy, Pandas. Then after that, we have to gather the data, split the data. Now we have to create model. So before creating model, first of all, we have to build a layer. The model contains a number of layers, right? The model contains a number of layer. A layer contains a number of, neurons. A layer may contains one or more neurons. Means what? Data or, arrays. Data in the form of arrays. Now, the model may contains, we can develop a model with one layer or multiple layers. And coming to the layer contains one neuron or multiple neurons. Right? First of all, I'll tell you how to build a layer in TensorFlow. Right? Along with the Python. So, the layer name is what? Layer underscore 0. TF. So, what is TF? TF is a package of TensorFlow. Right? Import TensorFlow as TF. Right? The short form of. So, instead of writing each and every place of in our code, writing import TensorFlow, simply we had used shortcut. Okay. Import TensorFlow as TF. So TF is a short form package. Now TF dot keras and layers and dense. So dense is what? A simple model which contains only a single layer. So if it is a simple model, yeah. Now I took a simple model which contains only single input, right? Mark underscore budgets. Only single column is there. So that's the reason I took a simple model which contains only one layer. Yeah. So this statement which contains only two parameters, units and shape, right? Yeah. Now what about this unit and what about the shape? So here shape means what? So I'm using only one layer because I'm creating only one layer. Now if you want to create multiple layers, now layer underscore 0, layer underscore 1, layer underscore 2, layer underscore 3, 4, 5, 6 and so on n. We can create multiple layers, but as per my example, just I am using only and developing a model with a single layer. Yeah, layer as created and which contains two parameters, units and so this shape indicates which gives the input to the layer. What inputs we are giving? Is it single value? If it is single value, scalar. If it is multiple values, is what? Vector. If it is a vector, whatever is dimension. Is it one dimension, two dimension, three dimensions or n dimensions? You have to specify. Yeah. So here this value 1. So this means what? Only one value we are giving scalar value. If you are giving multiple values, array. If it is one dimension, multiple values 1, 2, 3, 4 and so on. If it is multi-dimension means what? We have to specify like this. Rows and columns. Multiple rows and multiple columns. The shape indicates what? Dimension of input array we are giving to the what? Layer. Now layer contains what? Already I told you clearly a model contains multiple layers. A layer contains what? The model contains multiple layers. Layer 1, layer 2, layer 3. Right? Like that. A layer contains what? Number of neurons. Yeah. So this unit specifies 3. This specifies the number of neurons in the layer. Yes. So this is what? One layer. So this is what? Second layer. And third layer. For example, layer 1, layer 2, layer 3, layer 4. 1, 2, 3, 4. Now each and every layer contains number of neurons here. 1, 2. So in this layer only 2 neurons are there. In this layer only 1 neuron is there. In this layer 3 neurons are there. In this layer only 4 neurons are there. Now we have to define neurons. So we can specify neurons by using units. By using units parameter we can specify the number of neurons are available in the layer. Now in this layer just 3 means what? 3 neurons. Okay. So the number of neurons defines how many internal variables. Just neuron means what? Number of internal variables which holds the data to solve the problem. The whatever problem we have chosen. So in order to solve that problem, we require some internal variables. So these internal variables we can represent by using neurons. That's it. Now after creating the number of layers in a model, then we have to assemble it. We have to assemble all the layers. Yes. So like this. So input layer. This is what? Input layer. How many neurons are there in this layer? 3 neurons. Neuron 1, 2 and 3. Yes, correct. Now move to the the second layer. So this is what? Hidden layer, right? So this is what? Hidden layer. So this is what? Hidden layer. Now hidden layer contains how many neurons? 1, 2 and 3. Done? Yes, good. Now go to the third layer. So third layer is what? Output layer. So this output layer contains only two neurons, right? The output layer contains two neurons. Yes, yeah. So output we are giving here, inputs we are giving here, and we are getting. So this is what. So after creating layers along with the neurons, then we have to assemble it. Yes. Now how to assemble here? So in Python, by using sequential method, we can assemble it. The sequential model definition takes a list of layers as an argument, and it will combine it. So this is model we are going to develop. We are creating a model. Yeah. Creating model means what? We are combining all layers. Yeah. By using this sequential method, we can combine all the layers. Now, this sequential method which contains, parameters. Yeah. Only one layer I am giving. If you have to give multiple layers, we can give multiple layers. Right? So layer 0 I am giving, comma layer 1, 2, 3, 4, 5 and so on. Right? So as already in previous slide, we created only one layer with the 3 neurons. One layer with the 3 neurons. Units 3. We specified in previous slide, right? Okay. Now, yeah, layer 0, only one layer is there, and dense. Yeah, here I am taking here how much? Yeah, this model contains only single layer and number of neurons only one. The one indicates number of neurons, and shape is what? One dimensional array with a one value only. Yes. Now compile the model with the loss and optimizer functions. That means after combining all the layers, then we have to train the model. So before going to train the model with the input and output, already we gathered input, right? Right now we have inputs and estimated output. Now before training the model along with its input and estimated output, we have to compile the model. Then how to compile the model in Python? Yeah. So this compilation contains two parameters: the loss function and optimizer function. So the loss function in the model, before going for training the model, so the loss function is measure how far of predictions are from the desired outcome. It give us the error between actual value and predicted value. By using optimizer function, we can reduce it. Yeah, here, so this red data point indicates predicted value, and the green data point indicates what? Estimated value. Now this gap indicates what? The error between estimated value and predicted value. So that gap must be reduced. So this gap is what? This is what? Error. Then we have to reduce it. We have to reduce that error. Right? Now we have to train the model. So in previous 6 steps, the step 1, we have to create notebook. And step 2, we have to import dependencies libraries. Then step 3, gather the inputs. After gathering input, then we have to split into 2 categories. After splitting the data input into 2 categories, training data set and testing data set, then we have to create layers. We have to build the model, right? So create a layer with a different neurons. Combine all the layers, compile the model, then train it. So the calculating, comparing, and adjusting is controlled by fit method. So we have to use what? The fit method. So this fit method contains one argument is the input, and second argument is what? Desired output. Input and desired output. This is what training, right? How to train it? To train the model means what? So I am giving an input and I am giving estimated output. Giving input and output. Now how many times this process will be calculated, repeated? That means what? Epoch. The epoch specifies how many times this cycle should be run. So that is what epoch. Yeah. So we can train the model by using fit method, or the model already we created, right? The model contains n number of layers and neurons. We combined all the layers by using, sequential method. Now we have to fit it by using fit method. By using fit method, we can train the model, right? So this training the model, the fit method contains two parameters. X underscore train, already the data we gathered divided into two outputs, two categories, right? So X underscore train and X underscore test. X underscore train and X underscore test. Now we are training the model. We are at training the model, right? So while training the model, we have to use which one? X underscore train data set. Am I right? Yes. How many times you have to train it? 1000 times. Why 1000 times? In order to get accuracy. In order to get accuracy estimated output, I want to repeat it, this cycle 1000 times. Right? Once 1000 times, once we get the desired output, estimated output, we have to stop the model. Stopping the model means what? Yes. We train the model. Now, right now, we have a model which has trained. Now, this fit method will give us the object. So, we can use this object to plot how the loss of our model goes down after each training epoch. After each training epoch, 1000, right? Yes, in previous slide, had taken 1000. At each and every epoch, that means each and every cycle, how the loss of our model goes down. So we have to plot it. The high loss means that, the value of new subscribers gains the model predict are far from the corresponding value of actual subscribers gained. Why I am using here new subscribers gained and actual subscribers gained? I took the one example, right? In the month of January, we spent this much of budget, and the same month we got this many subscribers, new subscribers. So for each and every epoch, what are estimated subscribers in the so and so corresponding month? Now what about actual subscribers we gained? So then we have to reduce that gap. In order to that, we have to repeat the cycle. Yeah, fit method. Now we have to predict. So by using predict method, we can predict how much output we are getting. So this predict method, to have it calculate new subscribers gained for a previous known or unknown market budget. Yeah, we have to test the model, right? So after training the model, we have to test it with the test data. The input data is divided into training data set as well as test data set. Now we have to test. We have to test the model by using test data set. So just I am using here 80. Just I am predicting the model, because already I have a model, the trained model. Now I want to test it with a testing data set. Yeah. So we will predict labels for all the test data points, and compare them with the actual data points. So these green dots indicates what? Actual data points we estimated already. Now these red data points indicates what? Predicted. This means what? This one is the Y, So this one is what YP. So this is what estimated output, and YP is what predicted output. So this is what a gap error. This is the error. So this error we have to minimize it. Yeah. The total x underscore test we have to give it to the model. So now we are at testing phase, right? Testing step. So give entire. So previously just I have given only one value, right? Only one value I have given, right? Now we have to give entire test data. This. Now we have to verify the model accuracy using performance metric. Now we have to check goodness of fit. We have to check goodness of fit for the model using R-square method. So R-square is a statistic that will give some information about goodness of fit of model. That means how model is good according to the given training data. And R-square of 1 indicates that the prediction perfectly fit the data. Right. So from in Python, from sklearn matrix import or R2 square method, we can predict. So here assume that if you get output like this 0.9936534 something, that means what? As we can see this model, our model, whatever model we developed is near to 1. That means our model is predicting with a good accuracy. Now we are checking what? Goodness of fit of model. So if we get the output near to 1, so 0.099 means what is near to 1, right? That means what? Our model is good, is a good model. Yeah. So R2 underscore is a method. We can find out the goodness of fit of our trained model with two parameters. So we have to give what? Y underscore test, and second one Y underscore predicted. So we have to give what? Test, right, and predict. So now I am going to conclude the session today. Now in this video we learned about how to build a model in machine learning, right? In next class, in next video, we'll implement that model by using Python programming language in practical way. Thank you. Bye bye.
Like, share and subscribe. Hit the bell icon for more updates.